Hello, everyone. Welcome to today's Open Teams community event. I'm Brian Skin, the Open Source Architect Community Manager here at Open Teams, and I'll be your host for today. Open Teams is a single point of contact and procurement for expert technical leadership and other assistants to help you address your open source training solutions and support needs. Visit openteams.com or reach out to us at connect@openteams.com to learn more. As part of Open Teams' overall mission to sustain and support open source, we are also sponsoring the Open Source Architect community with the goal of providing a dedicated space for experts to connect and collaborate over their favorite open source technologies. To learn more or to apply for membership, visit openteams.com/OSA-community. Today, I'll be talking to Roman Yurchak, as the event title says, about client-side computation and data privacy. Roman is an ML engineer at Samario and a maintainer of Pyodide, a port of CPython to WebAssembly and Scripton, allowing users to install and run Python packages directly in the browser, tightly integrated with JavaScript if they need or desire. Roman's work with Pyodide has given him a lot of first-hand experience with the benefits and implications of expanding the range of what's possible on the client side, which we will get into. Thank you to everyone for attending. Please ask any questions that might occur over the course of the conversation into Zoom chat or Q&A, and we'll get to them as best we can. We are recording the event today, and that video will go up on the Open Teams YouTube once we have it ready. That'll be a couple of weeks probably. Subscribe there to be notified when it goes live. Right. Roman, hello, welcome. Thanks for being here.
Hello, Brian. Thank you for inviting me. I'm really happy to talk about these subjects today.
We appreciate your time. So I realized as I was preparing for this, I don't know exactly. Are you part of a maintainer team for Pyodide, or are you a solo maintainer there?
No, yeah. There is currently a team of 3 people who actually maintain Pyodide, and I'm part of that team.
Gotcha. So why don't we start with just a bit of your background, your education, your arc into programming, how you got involved with Pyodide, and what took you to the current point of your career.
Sure. So my background in education is that I was a physicist. So I was doing a PhD in high temperature physics, which involved mostly doing high performance computing, like to model some experiments that happen in physics, and also some data analysis. And as part of that, I ended up doing a lot of Python, a lot of scientific Python, and then programming. So I don't have a computer science background really. I have a physicist background, but nevertheless, most of the time I did programming. And then, so after the end of my PhD, essentially, I went into consulting. So I want to focus only on programming, and mostly on data and machine learning related topics. So I was also, at the time, I was also contributing quite a lot to the scikit-learn machine learning library, and so it made sense to go more in that direction. And also, I started contributing to Pyodide at the time, so it was around 2018, so it's like 5 years ago. At the very beginning when it was started at Mozilla. And my current position is so I'm still doing consulting for machine learning and data science related subjects.
Okay. Do you use Pyodide actively in the consulting you're doing, either directly or under the hood?
In some projects, yes. In some projects, not yet.
Okay.
Because it's still as we'll talk today, it doesn't apply to every kind of problem, but there are a few type of problems where it's very, very useful tool.
Gotcha. So what we talked about was kind of prior to the conversation was Pyodide kind of in the broader context of client-side execution in general. Browsers and there's the JavaScript front ends and that sort of a thing. Can you set the stage on the history, what led to even something like the nature of browsers, and then what led to even something like Pyodide being possible, bringing other languages into browsers?
Sure. So I think it's really interesting to consider how applications are being run on computers since the beginning. So initially, what happened is probably if you wanted to run some applications on a computer, you had to download something. Probably first it had to be mailed to you, and then you had to install them manually, etc. And the difficulty with this is first for users, it's time consuming. It's also a bit difficult because you have all those different systems, different operating systems. So you have different environments, like some things that don't install correctly, etc. And so what led to essentially more and more things moving to the server side. So more and more applications are just now a web page where you just go there, and some of the computing and data processing and all of that happens on the server side. And this has like essentially many advantages, because the user now don't have to care really about installing things. The company has access to all of the data, so they potentially, like more recently, they can train like machine learning models on that data. And essentially, they're fully in control of what's happening, so there's no problem of like some strange environments. And this became possible because you had the browser technology, which was developing and being sufficiently standardized and robust, so that like now you're pretty sure that if you do a web page, everybody will be able to open it. There will be no compatibility issues, etc.
Yeah, standard platform.
Yeah. And so that has been the way things are. So more and more things server side, which has its advantages for sure, but it also has some limitations, as we'll see today.
So I guess in terms of the technology specific, so for, again, and my understanding, I'm not deep into web development, so I'm somewhat potentially missing some things. Because we actually had an event earlier this year with Colby White on full stack web frameworks, which seems related but different in that what he was speaking over things like Next and Remix, where you're kind of eliminating the back end front end distinction to a certain extent. You have one tool that's kind of navigating both, whereas Pyodide is focused on. I guess you still are communicating with the backend potentially, but it's bringing more richness and complexity and different tooling to the front end. How do you how does Pyodide interact natively with things like Next and the modern full stack frameworks? Is that something that's done, that's a focus, or is that kind of tangential to Pyodide's mission?
So I guess like if you just take a step back, so at the beginning of browsers, you had just text, right? It was just HTML. You had some like static things, and then people added JavaScript to it to do more interactivity, and then people wanted to do more complex applications, which led to the development of those web frameworks such as Angular, Vue, React, etc.
Yeah.
And then because you had a number of web developers who were comfortable writing code in that framework. There was also like some other people thought, well, can we just do a single language that could work on the server, on the client, right? So that's like Node that allows you to just use JavaScript and just write everything in JavaScript, and so it's like easier for developers to work that way.
Sure.
And of course, you have also those like more integrated frameworks that you talked about, which allows to do both on the server and on the client. So that's like an interesting development, and it certainly like solves a number of use cases like for in real applications. And at the same time, so there was the need to somehow run not just JavaScript. So you have essentially JavaScript is a great language. It has a lot of like ecosystem and everything, but there's a lot of applications that are not written in that language. And so then you're either, okay, I want to do something for the web, so either I rewrite everything in JavaScript, or I put in the server and then communicate with the server. And so that's kind of, I guess, what led to the standardization of WebAssembly, and before there was a different like project called ASM.js, which allows to essentially like takes any kind of code, for instance C code, compile it for this platform and run it in the browser. And so now in a sense browser becomes this generic runtime, which is portable, so you can, like, the same binary, you will be able to run it on the browser in different platforms or different OSs, and that really allowed to have general computation in the browser and not being tied to the JavaScript. Not that like all the work that's happening in that ecosystem is not like very interesting and exciting.
Yeah, so that was where I was gonna head next was WebAssembly and the what it is and what it unlocks. So my understanding, WebAssembly is the it was something that browsers were basically sort of doing already with JavaScript. It's just the WebAssembly was kind of a formalization of it as a language, as a compilation target.
Yeah,
Is that
absolutely.
right?
Yeah,
Yeah.
absolutely. So first you had ISM.js, which was essentially an attempt to do high performance computing, like more efficient computing with JavaScript.
Hmm.
But then there were some still some challenges because it was not initially designed for that. And
Yeah.
so they a group of I think companies, uh, including for instance Mozilla, they standardized this, and so that's where you had in like 2017 the WebAssembly specification,
Hmm.
which defines the specification for this virtual machine that can execute any kind of code in the browser.
Hmm. Got it. Do you know, this is a bit of a random question. Is it at all similar to something like a Java bytecode system? Not JavaScript, but like the Java bytecode
Yeah, yeah,
language?
yeah, yeah. So I mean, there are, I guess, some similarities, but it's like on the implementation level is completely different.
Completely different.
But
Yeah,
yeah, I guess there is some I know some people compare this WebAssembly to Java because it's like a portable
yeah.
executable format.
Analogous, but not anywhere close to
Yeah,
identical.
yeah,
Yeah. Great. So then PyDide you said was created in 2018, so shortly thereafter. Were you involved in the creation, or
I
you
wasn't.
came onto the project? You were not. Okay.
I wasn't.
Um, can you talk a bit about that creation of PyDide? I
Sure.
assume, yeah, just to run with it.
So at the time at Mozilla, you had quite interesting group of people who were working on those subjects, and it was really very research and development work. So it wasn't yet clear maybe like how in practice you would apply that. So it was not like writing production applications. Like PyDI started really as an experimental project.
Okay.
So at the time you had you had two projects that were developed at Mozilla, which was Emscripten, which
Mm,
is this build tool chain, which allowed you to compile things first to ISM.js and then later to WebAssembly.
okay.
And at the same time, so Michael Drodboom, who is the creator of PyDide at
Yeah.
Mozilla, he was exploring the possibility of running Python with this toolchain.
Okay.
That was done as part of the bigger project, which is called Iodide, which was more focused on scientific computing or visual computing in the browser. So
Okay.
not specific to Python.
Okay. Um, and so the thing that's especially interesting to me, especially since there's the motivation being scientific computing, with all of the core packages, NumPy, SciPy, all the way up to PyTorch, being so heavily dependent on C extensions to run at reasonable speed. Um, WebAssembly if I understand correctly, as long as they're compiled a certain way, is it that PyDide can wire into that and leverage those speed gains, so you actually can use them at speed? Is that right?
Yeah, absolutely. So that's the really nice thing about WebAssembly and Emscripten toolchain, and so is that essentially it becomes really just a different build target. So as the same way you compile your code to run on Mac, you would just compile it to work for WebAssembly,
Okay.
and with relatively minimal changes, you will be able to get really good performance. So really near native performance. Of course, that's if you talk about just standard C code, right? But if you nowadays, if you look at scientific computing code, there is a lot of CPU specific optimizations that will be happening, and
Mhm.
those, I mean, they're being supported by WebAssembly, but it's still some time until you get really really
The
similar
finely
performance.
tuned the
Yeah,
truly
yeah, yeah,
finely tuned
yeah,
performance,
yeah.
right, right.
But for a generic C program, you would have a small overhead, but it's not a huge overhead.
Very nice. So that was, I know that I think it's Brett Cannon has been leading it.
Mm-hmm.
The use having WASM as a compile target for C Python, just as they build it,
Yeah.
right, directly from the project, which is cool.
Yeah, and that has been a really big step that as I was saying, so PyDide started really as something experimental, and then at some point, CPython developers were interested in this, and they essentially standardized like WebAssembly as one of, I think it's tier 2 build target. So it's now it's like officially supported platform for Python, and like that really helps. Like from the PyDide perspective, it really helped us not to have to, for instance, patch a lot of things in CPython that we had to do before.
And I know I've seen in the docs, points where it says not WASM, not inscripted,
yes.
where there's compatibility issues. So before we move into the data privacy topic, I just want to bring up the other project I know of that's Python that's at least seems similar, the Brython project. How is that similar or different to PyDide?
So it's similar. I mean, I think there were several. Like there's Brython, there is, I think, Sculpt is called. So essentially the idea is like we want to run Python in the browser, but the mean to get there is different because it was also started before WebAssembly. So the way they do it is by re-implementing the CPython interpreter, right? So the CPython interpreter is this the interpreter that takes Python code and runs and executes it. So you can re-implement it in a different way. So for instance, you have like the PyPI, which is a different interpreter for Python. You have the GPython, and so Brython is a different implementation of the Python interpreter.
Okay.
Right. But
not a completion target.
And so it works, right? So you can give it Python code and it will execute and will run. The difficulty there is because like Python in general is so dependent on C extensions. It means that you have to essentially re-implement each C extension because you cannot just compile it. Right. You can do it to some extent to the standard library. So you can make sure the standard library works. But then as soon as you have like some package that has C extensions, if you don't re-implement it, it's not going to work. And so that really limits your like the areas where you can apply it, because then you have to like all these compatibility issues are really difficult. And PyDide kind of sidesteps them by just taking the standard CPython interpreter and building it for.
Gotcha. You don't have to re-implement anything or much.
I mean, there's still some compatibility differences because you're in this environment which is quite rather specific. So some things you can do on your computer, you cannot do it inside the browser. So it's just like the constraints of the environment are a bit different, but aside from that, yes, it's like we have much less compatibility issues.
Speaking of that, I mean, I realize, speaking of that, we'd be remiss if we didn't at least mention PyScript, the Anaconda project, which Absolutely. is built on PyDide. And I completely feel the idiosyncratic limitations of the in-browser, like the security sandboxing and everything, because I explored PyScript a bit and tried to import several things. It's like, oh no, I can't reach out to the internet because sandbox, and I can't get to my file system because sandbox. But so I guess please, you're obviously PyDide is the basis for PyScript. Do you work directly with the PyScript team to
Yes, so one of the maintainers of PyDide, Hood, he's working for on PyScript. He's
cool.
working. Okay. He's being funded by Anaconda to work both on PyDide and on PyScript. And so certainly so PyDide is essentially the it's distribution of a Python distribution, right? So we build packages, we make it possible to start CPython like inside the browser, but then we don't really deal with everything that's like really user facing. So for instance, if you want some kind of widget or some kind of create a web page that does something, that's really not our we're not
the user has to build that.
And so PyScript, what they did is they really made it much more user-friendly to write Python applications in the browser using this HTML tags. And so especially if you want to address users who don't know Python maybe, or who are like newer, that's really a great environment, because again, with Python, one of the difficulties is how do you install Python. And and so that gives them just a web page when they can just edit some Python code, it will run, and they can also do like interactive visualization and interactive applications.
No, I'm very excited by what PyScript is going to unlock. I'm very, very happy that that's happening. All right, so let's go ahead and pivot to front end, the data privacy, the front end, the aspects of that for front end computation. Um, so we have again a number of topics we discussed in prep for the event. Is there any particular place you'd like to start? I mean, I think it seems pretty obvious to me that if you have these tools that let you write more and different kinds of code in the browser, you're going to be able to do more on that front end. So what are the
Maybe let's start by the challenges you generally have with the standard server-oriented architecture.
Terrific. Yeah, go for it.
For privacy. So of course, in the recent years, you had more and more because everything, like all the data processing, all the applications are becoming so centralized. Like the question of how private data is stored, processed, and managed became more and more important. And so you had several entities or countries or states that introduced legal legislations to essentially say how the data should be processed, stored, etc.
Yeah.
And so this, on one side, it adds really some legal, not overhead, but regulatory work you need to do to ensure that
the compliance burdens.
Yeah, compliance, effort to make it possible for your application to run, and that's that's unavoidable. Whatever, however, the way you deploy it. But we can see that because if you have a server-focused infrastructure, there are two issues. Is that you essentially collect the data for all of your users in one place. And so if, despite all your effort and despite all your security measures, there is a data leak, well, essentially all the data for all your users will be leaked, right? And that's a really big risk right now. And the more you accumulate data, the higher the risk gets.
And that's the headline is, oh, leak here. 500,000.
So and it's like you see that even from companies who are really for whom it's like the core business, right? It's not just you cannot. It's really hard to prevent that, right?
Yeah.
And of course, from that perspective, if you say, okay, I have some some sensitive application that needs to process users' data, so it could be private data, but it could also be well, still private data, but first medical data, right?
Yeah.
Is it really necessary to process it in centralized way? And maybe some type of applications you could actually process it on the client side and just return the result to the user, and maybe still store some information, some aggregated information, some non-sensitive information centralized in your database, but still minimize the amount of personal data that you store and you handle. And that's actually one of the principles of this legislation is for instance, I'm more familiar with GDPR, so the European part of the legislation, and so you have the privacy by design, right, which tells you that you have to design your applications in a way that's that minimizes the amount of data you need to handle, and that make it as secure as possible. And in some cases, so really staying client side, that's a way to achieve that, because so if you don't collect the data, you cannot leak, right?
You can't lose it.
Yeah. And even if imagine even if you have some vulnerability in your application, and because it can still happen, right? So you deploy a new version of your code and it has a vulnerability. Well, only the users who use it for a given time will be affected, and not all your historical users, right? So if you, for instance, deploy I don't know, your code today, and you realize tomorrow that there was some vulnerability there, only the users during this day will be affected, which is much less than usually all your all the existing users.
Okay. So what sort of, I guess the one question that comes to mind, so if with the data there's less risk of security, the privacy security aspect is stronger. What are the, how do you have to think about architecting something differently like the one thing that comes to mind is data backup and data integrity. If your data is distributed, you don't have control over where and how it's stored if it needs to be stored for some duration.
Yeah.
Um,
But yeah. So that's the other thing. It's like if you need to store it something, it cannot really be client side. So what we're talking about is more something that's like you need to get to process temp for a short duration of time and then return the result to the user, right? So for instance, I don't know if you have some medical images, you process them to detect, you apply some machine learning model them to detect whether there is like some kind of
Whatever the model
yeah,
sees
whatever
to
you're
detect
detecting,
something. Yeah.
and then you return the response to the doctor or whoever the user is. In that case, you don't necessarily need to store. I mean, you can totally do that on the client side. Of course, if you're like I don't know, if you're doing a registration form for this event, well, you cannot really do it client side because you need to
Then I don't know who
you
it
have a
is.
list of
Yeah.
participants. So yeah.
Okay. So it's never going to be completely delegating the entirety of the data of an application to the client because
Yes.
they're just you can't do that.
Yes,
Okay.
you can do that. Yeah, but for instance, more recently, you had all the developments with like large language models.
Hmm.
So of course, it's as of today, it's difficult to put a large language model in the computer and just distribute it on each web page. But like all the privacy things that like you're currently sharing with centralized servers, like
Yeah.
you're basically essentially sharing your discussion. One day, like some number of years from now, you could just say, okay, I'm just going to do it on the end device, right?
Hmm. Yeah, I mean, I know, like, was it quantization, and there are the other methods inside the models to try to reduce the payload size so that
Yeah,
it's
yeah,
easier to deploy client side
yeah,
while not
absolutely,
losing
absolutely.
accuracy. Yeah,
There's
yeah,
still like, I mean, okay, but so you can like today it's very practical to do that with classical machine learning models,
yeah,
because classical
absolutely.
machine
Yeah.
learning models you can reduce them to a fairly small size. I mean, large language models, there's like great work on like reducing the model, but it's still like it's still huge. So
Hmm.
it's still not something you will go to, I don't know, some random website and it will just load gigabytes of data. I mean, that's not going
Well,
to
it
happen, right?
could, and then no one would use it
Yeah,
because it would take
yeah,
2 hours to load. Yeah.
yeah.
All right. Um, so in your work with Sumerio, I'm guessing that you try to apply this. Have you what sort of can you
Use
give
cases.
right? So what sorts of use
Yeah,
cases have you
yeah.
personally implemented?
So one big use case currently of Pyodide in particular
Mhm.
is teaching. So for instance, in France, in high schools, the problem they faced is they so nowadays they it's in the program to teach Python, right? So the programming is being taught in Python,
Okay.
and essentially professors or like teachers in schools, they're not really IT people, right? So they just need some way to show how to use Python, but without installing Python, because if you ask high school students to install Python, it's not working.
Mhm.
So the first thing they did is they tried essentially to run just big centralized servers where students could run their code and then execute their code. But the problem is they have really like thousands and thousands of users, and it was getting quite costly. So it's like it's a public institution, they don't have like a huge amount of funding, and even if they did, they don't want to spend it on computing.
Right.
So what they did is essentially to move the computing to the client side. So they used Pyodide, and they used in particular Jupyter. So
Hmm.
there's a fork of Jupyter. So I mean, there are several variations. The fork they're using is called Baston. So it's a fork of the classical Jupyter notebook. It's
Hmm.
developed internally by them. But eventually they will shift to Jupyter Lite, which is this more standard build of essential Jupyter Lab,
Right.
but for the browser, right?
Okay.
And they have some application on top of that to allow for teachers to be able to grade students and to give them homework and things like this.
Hmm.
And that really allowed them to deploy something to literally, I don't know, tens of thousands of users
Hmm.
with very, very minimal cost, because then they don't have to pay for computing, and they don't have to deal with
Yeah.
it. And it's not even just computing, it's also infrastructure, because if you want to handle that many users, okay, you can go to the cloud, but that's probably the way to go. But then you also have well, you do have privacy concerns. So because then means that personal data of your students end up in the cloud. So yeah, you can go to do some encryption. I mean, there are mitigations you can do, but it also means that your infrastructure is getting quite complex, and like there's a complexity involved into that, because if you want to scale, some of the things is done by the cloud, but you still have to manage a lot of things, right? And while in this case, essentially, if you ship something client side, you don't really care about this the number of users, because it's just like you just distributing static files, and no matter number of users, you're still doing the same thing, right? And the cost is really minimal. It's just like downloading some files, so it's not like big factor.
Okay.
So that really allowed them to do something that was not possible before.
Very nice. So there's still like a core student registry that's held server side centrally.
Yeah. So it's still a mixture of server side and client side. I'm not saying everything should be moved client side, but you can move a number of things client side. And so for them, for instance, it allowed them to self-host all of this relatively easily, and also ensure that the privacy of their users is preserved, and that they don't have to share the data they don't need.
Okay, so it's what is it? The analogy that's coming to mind, it's been a long time since I've been in school, but like the Blackboard sort of systems that are the course management software. Is it serving that function as well, or is it just
it's more like programming exercises?
Okay,
so it's
the educational material itself.
Yeah, it's like programming exercises in Python, and
Okay,
so it's not the full course. It's really the programming part.
Got it. So it's not like handling math and reading.
No.
Just for the program. Gotcha.
The other use case I can maybe mention, it was done in the UK. I'm terribly sorry. I forgot the name of the organization that did this, but
we'll find it afterwards to put it in the notes.
Essentially, the problem they had is they had many like local organizations like in UK that had to deal with some kind of data, and essentially what happens now, if you want to, for instance, you're in organization A and you want your data to be processed by organization B, you have to sign an agreement for data processing, right? And then the more organizations are involved, the more complex it gets, because then everybody involved needs to sign something. So it's like pretty complex.
Yeah.
And so essentially what they wanted is some way to process data about I think it was children's data. I'm sorry, I should have noted this better. But essentially, they wanted to process private data without sending it to the end server for whatever IT supplier could do the processing, right? Because that would involve a lot of legal
extra paperwork
overhead, right? Yeah. And it's time-consuming, money-consuming, etc. And so what they did again is that they moved part of the processing directly inside the browser to the clients, and so that way they could do some of this work themselves without actually having to share any of the data.
Excellent. Okay.
So those are the kind of use cases essentially you can think of. Of course, it's not. It doesn't solve, it's a tool. It doesn't solve all the problems with privacy or security, but it facilitates significantly those issues.
You have to make it has to be a conscious and well thought through choice, though, because some of the things that you mentioned in terms of limitations, you are then limited to the capability of the client's machine. So, for example, if here in the States, I think a lot of schools get Chromebooks, and some of those can be relatively low powered. So maybe talk about that a bit, like the sort of the thought process that you kind of have to go through. It's like, we could do this.
Actually, on that particular examples, like the mobile CPUs are getting really, really good. So maybe that was you're not going to do like very extensive computing on that, but to do standard Python things, it's fully sufficient.
Interesting. Okay, so that limitation is now and in future not terribly tight. Then you've got a lot more options there.
Yeah. So I think for instance, in the particular case of PyDide, we're still the overhead of using Python in the browser is still significant compared to running it natively. Like this is specific to the Python, so we're still investigating why and how we can optimize that. But I mean, those are things that will be optimized eventually. So it just like takes time and effort. But I would say that like the resources on the end machine are not necessarily a limitation, because like you can like now you can use PyDide or PyScript on your phone and it works, right? So it's fine.
It's wild.
It's more and furthermore, like actually like the phones now have actually decent GPUs. So if you want to do some kind of machine learning or like AI, essentially you can potentially use the GPU there and not have to pay for it on your server, which is expensive.
Yeah, I mean, I know I've definitely read headlines and things about exploration into running inference on mobile GPU. So yeah, lots of development to come there probably as the technology, the hardware improves.
Yeah, absolutely. So I think so you have two projects that I'm aware of. So you have the ONNX project, which allows you to take any kind of ML model and export it, including to the WebAssembly. And so you could run it in the browser. And like more recently, you had Hugging Face, who did, I think it's called library transformer.js, which essentially to take any kind of model they have and export it again for the browser. So there's like tooling that's being developed to make this easier and like more efficient.
Very nice. Yeah, I mean, it makes sense that from the tooling side, the broader usability that their tools can have on different devices, the better for, uptake and durability. All right. What are, and this might be kind of hard, maybe it would be best to cast this in the context of one of the use cases, the actual studies or case studies that you worked on. What do you find you have to think about differently as you consider moving pieces to client side, in terms of, do you have to architect the project differently, substantially differently? Do you have to think about like the actual logic flow differently? What is the brain breaking aspect of trying to move from the old server centric model to the client, the partially client based model?
So that's like an interesting question. It's like, in practice, what are the challenges? So essentially, one of the goals of PyDide is to try to smooth those differences and try to make them as small as possible, when as possible, right? So for instance, imagine you want to download some data from somewhere, right? So on your computer, if you do that, what happens is you have to open a socket and connect to the remote server. Like in the browser, you don't have access to sockets. So it means that any kind of interaction with a remote URL in the browser needs to happen through JavaScript. And so what we did, for instance, in PyDide is to try to like both in PyDide, and there's another project called PyDide HTTP, is to try to essentially re-implement Python functions that, for instance, do data fetching underneath in JavaScript, so that for the users it would be kind of the same, so it wouldn't change anything. But
a wrapper API, basically.
Yeah. But the implementation underneath would be different, right? So for instance, this thing is transparent, but other things are still not really addressed and might not never be addressable. So for instance, if you want to open a connection to a database, that's you need to open a socket. So it means that that's not possible in the browser. So in the browser, what you have to do is you have to have some proxy server that to which you connect, and that proxies your connection to the database or some other specific network oriented protocol. So there are like some limitations like that. Or I don't know. Imagine you want to send an email from your program, right? I mean, on a Linux machine, you can just send emails just directly from the machine. Here, certainly, you would need to connect to some email service to do it, and even then, you might need to have some proxy again to make sure, because again, like EMAP and all those network protocols, they are not designed for browsers. So you might need some adaptation in those cases.
And the service would have to have an API that exposes all the different bits of the email composition or whatever you're trying to. Yeah, right. Okay.
There are some so where it's easy now, it's pure compute. If you just want to do compute, that's really straightforward to do. If you want to do interactions with your data, I mean, you can anything that exposes an HTTP endpoint can be usable, right? Can be accessed for a browser. But anything that uses like low-level network protocol, that's more difficult. And of course, like databases have also, I think they're like depending on database, you can have some kind of HTTP API to access it, but it's still it's still a bit of different approach from what you would normally do.
No, that makes perfect sense, because what I was trying to do with PyScript, and with like one of my open source side projects, it handles the object inventories produced by Sphinx when you build HTML docs, and it's set up so that it can reach out and grab a file and download it and process it. But I realized, oh, I can't download a file into the sandbox. I can, get if I'm going to use this, I still have to have my backend that then goes out and fetches the file, serializes it, pipes it through a call, and then I can have it in my PyScript and in my Pyodide.
Was it a local file or a remote file?
Remote file.
So
I might have just not known how to do it correctly. But,
I think that should be doable. I mean, just getting a file from remote to URL, but you might need to install like an extra package that does this.
I think that's what it was. I was just trying to, because URL lib couldn't retrieve, because there was no SSL package.
So we wrapped for instance, we've wrapped requests, but we didn't wrap URL lib. So some of the packages are wrapped, others not. But those are the small things
me finding the right tool there. But right. Okay, that makes sense. Now this was helpful for me. Now I know how to move forward there. One thing that occurred, so you were pushing the computation to the client side. In your experience, what sort of effect, and again, you said that the capabilities of the client devices are improving all the time. Do you see substantial responsiveness challenges in terms of just, since you're delegating computation to the client devices, does that slow things down? Does it speed things up?
I think it depends on your budget, and it depends on your application. So if you don't care about the compute budget, you can certainly make things faster on the server side. But if you're like, I don't know, one case that I find interesting is that imagine you have some application, right? So you deploy it. And now, if you want it running, you have to pay each month for some machine to run somewhere. You have to manage, like maybe you don't manage the software updates, but somebody has to manage them. Maybe it's like the cloud provider. So it's like a physical thing that runs somewhere, and like if you stop paying for it, your service goes down, right? Well, in this case, you just make some files accessible, and it's actually much easier to make some files accessible like for the next 10-15 years than it is to pay for some compute resources that you're not sure if next year we'll have the budget for it, and like, I mean, maybe you'll change like the cloud provider or something. So it's like there's a lot of restrictions there. So I wouldn't say like performance is not the question is a bit maybe difficult in the sense that there is no way to say yes or no, it's faster forward the client.
Too contingent on the application.
But I would say it's like you can make it performant enough on the client to answer your business needs.
Okay. Looking forward to the future, both technically and in kind of the broader regulatory environment. Let's do Pyodide first. The project has at least a wish list. Do you have a roadmap, wish list? What are the big near to medium term goals for the project?
So my personal goal, like I mean, we have 3 maintainers, and each of them are working on the subjects that like interest them more. The personal subject I'm working on is trying to reduce the size footprint, because like if you want this to be really usable by people, you want the download size to be as small as possible. So right now we're around 5 megabytes. Like, so this applies to Pyodide and PyScript, right? So 5 megabytes is not huge, but it's also not something you're going to put on any random site and like because it's still going to take a while to load, like especially mobile maybe. I mean, as time goes by, like networks are getting better and better, but it's still like not negligible. So we're trying to reduce a bit the size and the footprint and also the load time. So their activity. Other things is like packaging, but packaging is a difficult problem. It's like how do you package, how to make accessible the Python ecosystem for the browser. Somebody needs to build the packages. It's not a very rewarding task because package, like there are new versions each time, some things break, so it's like it's really a lot of effort.
Well, like Python 3.12 was just released, so that's another round of wheels that everybody has to generate.
But I would say it's like the Python updates is not such big of a problem. It's more like individual packages. It's like you have so many packages, and then some of them are really hard to build, and it's difficult. But indeed, like we're also looking forward to updating to Python 3.12. And then and then maybe trying to make things a bit more modular. So for instance, now the development, the WASM support for CPython is done upstream. So we're happy that like maybe more user-facing things are done in PyScript, and then maybe we try to make PyDad a bit more modular, so it's like not the big. So I mean, we do have a roadmap. You can have a look at our roadmap. There are more technical points that I haven't raised here, but so some ideas of the things that we're looking forward to.
On the topic of 3.12 and like 3.11 and recent as well, how has the kind of the faster Python push, that like the 5 times increase in speed over 5 years or whatever the plan was, how has that affected Pyadide? Have those changes?
I haven't tested yet 3.12. 3.11 we certainly saw the same speed up as on the like native system. So you like it was faster, but because we still pay for the overhead, we still have this overhead. So it's like it was faster than before, but it's still there's still work to do. I think specifically for Python in the browser. How do you optimize that? Because like it's a bit like the runtime is a bit different, so maybe the optimizations need to be a bit specific. But overall, I'm also like really excited about all the work on making Python faster that's happening. And actually, so Mike Drodboom, who started Python, he's now working for the team for faster Python.
That's right. Okay, at the Microsoft team there with Guido and okay. Then as well, there's I had it and now it's gone. The another way of compiling to WASM, I think it was. Oh well, it's gone.
Was it? You mean?
I don't think that would be something. There was something else that came to mind that it is now gone. So LPython.
Oh, but LPython.
So that was we had Andre on an event last month where they have their intermediate ISR abstract semantic representation that then they compile to transform to that and then compile to backends, and WASM is one of those backends. Is that something that would be, how would that work? Could an LPython application or tool, because it compiles to WASM, is that freely, does that work well with Pyadide, or is it like kind of like a parallel? Would that be challenging?
So LPython is from the Fortran project, right?
Correct. It is analogous to Fortran. Yeah, the Fortran takes in Fortran, LPython takes in Python. Then they both go to the same ASR and then down to the C++ or the WASM.
Okay, I haven't actually looked into detail what LPython does yet. So it's probably like I did see the announcement, but I haven't looked in detail.
I'm guessing it wouldn't integrate directly with Pyadide because it's outputting, because Pyadide is taking in Python code and running it on the WASM layer. So it's another approach, but it's probably not directly integrable. But
so for Fortran, we're really looking forward for actually this all the work that's being done in Fortran, because one of the difficulties we have with scientific computing is the Fortran files. There is no standard Fortran compiler for WASM. So now we do a lot of hacks and like converting to C and all the things to build like things like SciPy, but it's clearly not sustainable. And like, so we're really, really hoping for the Fortran project to do this like, in a more better way, so we can just use that.
Okay, so there may well
So
be a point of integration down the line for if
yeah,
since
certainly.
Python can wire into the same machinery. Okay.
Certainly. And like apart from that, in terms of compatibility, yeah, I mean, you can if you have like two executables in WASM, you can use both of them in the same page and then communicate through JavaScript. So just like you have to convert things back and forth from JavaScript. So maybe there is some more efficient way to handle arrays and things like this, but fundamentally you're communicating through JavaScript.
Okay.
And then if you're like really talking about packages, so for instance, like Pydight is not the only project that builds wheels for WASM. There's also Encrypt and Forge, and essentially it's a matter of binary compatibility. So it's same as with it's with standard Python. So if your wheels are compatible, build for the same Python version, and then with the same like essentially tool and like flags, you can like, that's what we try to get to, is that essentially wheels built by other people, including Encrypt and Forge, can be used with Pydight and the other way around.
Okay, just installs right in. Very nice. All right. I guess the other future question I had, we've got GDPR. I know there's a California law. I don't know the details about data privacy and these sorts of things. Are those still the main players in terms of the future regulatory environment? Is there more in the works? What sense do you have there?
I guess that there will be more of the regulations concerning everything AI related, and also some machine learning. So I mean, I think right now what's regulated is like some industries like insurance, or like in terms of what they can use as data, what can do with the models, and that will probably get more more formalized in the future.
Yeah, we had the event series back in January this year with around PyML and interpretable ML, and that is absolutely. I think there was a lot of financial representation there, which is obviously you have to know why your model is making the decisions it's making. So, this has been terrific. I don't have any other specific topics. There weren't any specific questions that have come in so far from the attendees. If there are any, please drop them into chat real quick. We'll get them answered. But otherwise, I think that's it. Any last thoughts about the topic?
I think it's like great talking to you. I think it's like a really it's a pretty exciting topic. It's like a lot of things has been happening there in the last years, and like now it's getting to the point where it's getting fairly robust, and like people are actually relying on this to build concrete like solutions. So there's also, but because it's still an early technology, there's also a lot of room for optimization, for improvements, and for making things better.
Indeed. Yep, likewise, it was a pleasure. I knew of Pydight, and we did have a question come in. I didn't see that. Aha. What are the long-term challenges to ensuring the sustainability of Pydight? Any particular risks?
So as with any open source project, there are certainly sustainability concerns. So Pydight started Mozilla, and then Mozilla progressively worked less in it. And so we spun out as an independent like open source project now. And I was personally very happy that we managed to attract two other maintainers. So, okay, 3 maintainers is not like perfect, but it's already like it's not one, right? And so we try to keep like a balance of different, so there is not a single company that funds all of the maintainers, and like to keep a balance between like sustainable environment and have different funding sources and things like this, and also maybe trying to reduce a bit the scope. So for instance, if packages are built by other organizations, then we have to do less work, so that it can be also more sustainable, right? So there is there's certainly like sustainability is a pretty like important subject like for any open source project, and that's something that we do think about.
So you mentioned the Inscription forge. Is there a Pyodide forge in the future?
No, yeah. So we're trying to move packages. I mean, first we're trying to we have built tools so that people can build packages themselves as you would for normal Python, and then there's also like some work in progress to make it possible to upload those packages to PyPI. So you would like, so anybody could just build a package, upload it to PyPI, and then we don't have to host it or deal with that.
Nice. I guess along those lines, if for anyone interested in getting more involved with Pyodide, what's the best place for them to start?
I think a good way to start is have some example of problem that you would like to solve. Like for instance, in your case, you're like documentation is also a great use case, because like more and more projects are trying to do some interactive documentations with like running in the browser, right? And so, but is to have some project, try to do it, and then if you have any questions, just contact us on GitHub or open an issue. We'll be happy to.
And then for contributions, I assume standard open source, raise tickets, discuss and open PRs and normal flows there.
Yeah.
Cool. All right. We are recording the event. The recording will be up on our YouTube. Subscribe at the OpenTeams YouTube to get notified when that goes up. Please check out openteams.com to learn more about us and our offerings, and we'll see you next time.